Hello everyone, in this video I'll be solving the problem mark points, and it was asked in CodeChef contest startup 201. So this is the second problem that they've asked. Let's try to read out. There are n equi-spaced points numbered 1 to n initially. Initially all points are marked. In one operation you can choose x such that x is greater than 1 less than n. It is one based indexing basically. So then mark points x minus 1 x plus 1. Okay, so if you choose x, you will be marking previous, current and next. If any of them are already marked, they do not get affected. So once any elements are marked, that will remain as marked only, even if you mark 2 times. So finally you will make a binary string f where s of I is equal to 1 if and only if you marked points I, and otherwise if s of I is equal to 0. Okay, got it. So now you forgot what operations you did. You have a binary string s with you. You want to check if it is possible to obtain s by doing some of the above operations of marking points. Print yes if it is possible to obtain s, no otherwise. Okay. Okay, this is easy, don't worry. So they have given 7 examples. In the first example, uh, n is 3 and s is 000. Let's try to understand this. So what they're saying is, initially they have n points and they are equally spaced. So you can think of array only. Let's take array or something like that. So you have n points. Okay, n points, and initially all are not marked. Not marks are denoted with 0. And in the operation what you'll do is you'll choose index x that is greater than 1 and less than n. So this is one based indexing up to so on n we have. So you when you're choosing any index x, you will be marking x minus 1th index x and x plus 1 index. So when you're marking, which means you're doing you're writing with 1. Let's say in this case x is equal to 3. So what you will be doing is you are choosing 3. So x minus 1 is this one. This will be marking, which means you will be denoting it binary 1, and x, which is this, and x plus 1 is next element. So this is the state right now. So and you have forgotten what element you were marking, something like that. So this is one of the intermediate stage you can think of. So in the same way, this is the intermediate state you can think of, they have given, and you have to uh, tell that this s is valid or not, he have marked according to these rules or not, that will have to say. So this is very straightforward. This is a trivial case because all are 0 elements, which means he have not started marking. So when you have not started marking, initially I have showed you all the elements were 0 only. So in this case n is 3. So if you see all elements are 0, which means you have not started marking. So in this case you'll have to return yes. This is the case wherein initial this is the configuration. So yeah, first one is yes. Let's try to understand the second one. This is also trivial. You have n as 4, s as 1 1 1 1. So if you try to see, you have all 1 1 1 1, right? So this is the case wherein what you'll do is, let's say you have chosen initially, let's say you have 0 0 0, and this is one based indexing, right? So you will choose x. Let's say I'm choosing index 2. So when you're choosing index 2, you will be marking the previous, the current and the next, and this is the state. Now let's say you choose index 3. Again in this you'll choose index 3. So now your array will look something this way. This is marked, this is marked, this is marked. So you're choosing this one. So previous one is already marked, so it is 1 only. Current is already marked, that is 1 only. Next one is not marked, so you will be marking. So whenever all ones are there in the S, which means this is also a trivial case, which means this is the final configuration. So in this case also you will have to output yes, right? Okay. So yeah, this is the case. Now let's try to understand this one. 0 0 0 1 0 1. Okay, we have NS5 SS 00101 C. In this case it is easy only, I mean if you try to think of. So what you have is 00101. Okay, so this is not the answer, we can say. In this case we'll have to return no. Why? Because let's say any configuration if you choose, so you will be marking its previous element, current element and next elements. So whenever you find one in the string, so at least there should be a 3 continuous of 1, right? So because of this condition, whenever you are marking the previous element, current element, next element you will be marking. So in this case if you see, you have marked this one, you have not marked previous one, you have not marked the next one, which means this is not a possible configuration. So this is the main thing of the problem. Like if you see one in the string, it should be the count of that string, continuous string has to be greater than equals to 3, then only that configuration you can say that is marked. So in this case as you can clearly see, we have only one, which means the previous is not marked, the next is not marked. Here also if you see, the previous is not marked or current is not marked, you can say. So in this case you'll have to return no. I think you guys got to know. So if you try to see this one 001 011, what we have example 011 0111, we have 011 0111, this is yes, and n is obviously 7, right? We have 0110111, right? So if you try to see now, in this case if you try to see, so this is a valid combination because chef may have chosen this index, he has marked the previous, he has marked the next, but this is not the valid configuration. We have ones, but it doesn't have, I mean continuous ones does not have count greater than equals to 3, which means let's say if he had chosen this index, so in that case he would have marked this current, next and the previous one, but previous one is 0, which means this is not a valid. If you happen to use this one, so previous he has marked, current he has marked, he has not marked the next. So in this case the configuration is not possible. So let me take one more example, and wherein there are 3 yeah, in this case if you see, we have 3 continuous, again in this we have 3 and we have 3, so that is a valid combination. So one more case let me try to discuss. Let's say you have this one, so in this case you have 4, so this is also a valid one because let's say you have chosen index this one, so he has marked previous, current, next. And how this one is marked? So this one is marked by using this index. If you have chosen this index, he will be marking the previous. Since it is already marked, even though it is marked, it will not affect anything, and he will mark current, he will mark next. So the main crux of this problem is the continuous one ones has to be greater than equals to 3, the continuous ones in the string. So yeah, let's try to solve them. What I'll be doing is in the question they have told they'll give n strings. Where is input? Yeah, number of test cases and n points, and they give an SS binary string. So test cases have handled here. This is n. Let me call string s, c in s. Now I'll have to take one count into one count. So that is initialized to 0, and I'll take one boolean variable found 1. I'll tell you why I'm taking, and initialized to false. Initially we have not found any one, so that is the reason. So now what I'll be doing, I'll be running a for each loop wherein your character will be from string s. If you find that cs is equals to 1, because since it's a binary string you have either 0 or 1, so if it is 1, so what we'll be doing is you will make this boolean variable as true, and you will increase the 1 count by 1 because you have found 1. Else, which means the current element is 0. If current element is 0, you will have to check like if the 1 count, first you will have to check like you have found 1 or not. Like if you have found previously 1, which means this found will be true, and once you have found previously 1, now you'll have to check if that one count is greater than or equals to 3. So in that case your answer is valid. But let's say you have found 1 but your one count is less than 3, so your answer is not valid. You'll have to take one flag variable, set it to false, and break out of the loop. Even if you find one continuous ones wherein the count is lesser than 3, so you'll have to break. So I'm taking one flag. Initially I'm setting it true, which means we have answer. But once we found out that one we have found and its count is less than 3, so we'll break out of the loop. If we have found one and the one count is greater than or equals to 3, in that case, since the current element is 0, so you make found as 0 and one count one count is 0 and found 1 is false, because you have not found no 1. So, and at the end what you'll have to do is you'll have to check if your flag is true. So in that case you'll have to output yes, else you'll have to output no. Why I have taken this found variable? Because let's say your any case you can take. Let's say you have taken this one, this case wherein you have 0 0 0, so your found one count will be 0 only. 0 is less than 3, so you'll be breaking out of the loop. But this in this case you'll have to output yes, right? So that is the reason you should have previously seen the ones, and now you're basically taking care of count variables. So that's the reason. Let's try to run it. Somewhere it is failing. Okay, here it is failing. Okay, got it. Why it is failing? Because at the end you have continuous ones, and it is not true, because at the end like at the end in this if condition you will go and you will come out of the loop. Now when you are coming out of the loop, you will have to check again here if found one is true and one count is less than 3. So in that case you'll have to print no. Let's try to run it. Okay, this should be if else if, because if this is the case you will be printing no, and you're not basically checking other if else, right? So yeah, small mistake. Let's try to copy paste this in the CodeChef editor. We should be getting yes yes no no yes no no. We're getting yes yes no no yes no no. Let's try to submit it. Yeah, it got submitted. So in this way you could have solved the problem. I think the main crux is that if you have continuous ones in the string, and that continuous one count has to be greater than or equals to 3, so that is a valid one. Even if you find like a single continuous ones wherein its count is less than 3, so in that case it is not a valid binary string. So yeah, thank you guys for watching the video.